All right, so this is lesson 11B area under the bell curve. This is called the normal distribution. This is a bell curve. So go ahead and copy it down. All right, so a normal distribution curve. There are a lot of data that is normally distributed, like the SATs. You guys know the SATs, standardized test that they had stopped taking, like those Ivy League schools. They stopped taking those SATs. They didn't require them for a while, for like a couple years, until they found out that some students that were admitting didn't really know basic stuff. So this coming up year, they're gonna bring it back again. Then we used to have what the high school exit exam, like long, now it's been a long time, 5 years. I don't know when they stopped doing the high school exit exam because it was unfair or whatever. But whatever. Okay, so the normal distribution curve kind of just says that under the bell curve is 100% of people fall in there, say for whatever it is, no? So say the SAT. So the SAT has everybody, whoever takes it, the population, whoever takes it, that's going to be 100% of those people. And so this is what the normal distribution curve says, that more than likely, sorry, what your mom told you that you're special, but more than likely you're average. So the average is whatever the average is, no? Whatever the average, say for the SATs, is at a 1600, and then the average is like 1000. So whatever, no? So the average is right there in the middle. So one standard deviation to the right and one standard deviation to the left, 68% of people fall within there. So out of 100 people, 68% or 68 of those people taking the SATs will fall within there. So if that is 68%, then that means that this area right here, 34% of people fall within this area here, and 34% fall within here. And that is 68%. That's within one standard deviation of the mean. 68%. Two standard deviations from the mean. Two standard deviations from the mean is going to be 95% of people fall within there. Two standard deviations from the mean, 95% of people fall within there. Okay? Now, let's see if we can do a little bit of math again. Oh man, look, hold on, let's do a little bit of math. If this area, I'm telling you, this area right here is 68%. This area right here is 68%. Okay, this area is 68%. And this area, let me use another color. This area right here is 95%. Then how much is this and this? That's an SAT question. You're like, teach me. Figure it out. That's the whole point. I'm saying one more time. If this is 68%, this in red, this is 68, and this This is in whatever this color is. This is 95. Then how much is this and this? Anybody? 13.5 is correct. How did you do that? You're like, I use my brain. Huh?
Subtracted 68 from 95 and then
Divided by 2. Duh. So this is 13.5%, and that over there is 13.5%. Okay. 3 standard deviations from the mean. Either you're getting really, really smart, or you're getting on the other side. 3 standard deviation from the mean. 68, 95, 97.5. So 97.5% of people fall within 3 standard deviations of the mean. 97.5. Like a radio station. 97.5. 97. 97.5? No! I knew I was wrong. I was like, how can it be a radio station? I was like, no. 99.7% of people are within 3 standard deviations of the mean. What does that mean? Out of 1,000 people, that take the SATs, if you're in the top 2 out of 1,000 people that take the SATs, you're getting very special there. You're like, that's where you start getting Harvard emailing you saying, hey, you want to come visit our campus? So how much is this then? How much is this? How much is this? And how much is this? How can we figure it out again? Which is 2.35? That is, and what are you doing? Subtract 95 from 99.7 and divide it by 2. 2.35%. Yep. So basically, if you fall on the tail end on the right side, say your score is right here. You take the SAT and you get this score. Your score is right here, right here. Your score is right here. Meaning you're doing better than all this right here to the left. All of this. So you're doing better than, add this up. Can you add up all this? You're doing better than all these people. Well, look. I'm already getting into the lesson. Would you agree that from here, this way, it's already what? From the middle, how much is this from the middle to, how much is this already? Do you know that half is 50 and half is 50 is 100? Yes or no? So you're already doing better than 50 here. So what's 50 plus 34 plus 13.5 plus 2.35? Real quick, get your calculator. What is 50 plus 34 plus 13.5 plus 2.35? 99 point what? 98 point something?
99.85.
Really?
Which would make sense because instead of 0.5 and there's 0.35.
50 plus 34 plus 13.5 plus 2.35. What? 89? You said 89?
It's a 99.85.
50 plus 34 plus 13.5 plus 2.35. 99.85. So you're like the top one out of 1,000. And if you're like, if you get a score right here, that's how kind of how the bell curve works. So examples of data that is normally distributed, the SAT results, scores on a math test, could be IQ test. You take an IQ test, the average on the IQ test. What do you think is the average on an IQ test? What do you think is the average on the IQ test? A 100. 100 is the average. We're going to go over that in a bit. The height of people. Yeah, I guess. Sure. But even within a certain population, there's you can put them and they're different than another one. Like, you know. Do you guys know who's what country has the tallest people on Earth? What country has the tallest people on Earth? Country. What country has the tallest people on Earth? The Dutch, the Netherlands, the Dutch. They're about the guys are about 6 foot tall, 6 foot on average, and the girls are about 5'10" or something, or 5'8". I don't know. A girl on average in the Netherlands is taller than me. Let's go to number one. Let's go to number one. All right, let's go. Let's do problem number one. Write it down. I wish I was taller. Oh, they made a song on that. Anybody know I wish I was taller? No? Anybody know the song I wish I was taller? I wish I was a father. Huh? Who is it? Who's that? Do it makes life so much easier if you were just tall? Suppose that IQ scores have a bell-shaped distribution with an average score of 100 and a standard deviation of 15. What percentage of people should have an IQ score between 85 and 115? Don't say anything. Don't say anything. Hold on. That in itself right here I could already tell you, like, if you can get this, you have at least you're normal. If you know the answer, the answer to this. Who knows the answer to this? Raise your hand if you know what the answer to this is. Raise your hand if you already know the answer to this. No, it's asking what percent of people should have an IQ score between 85 and 115. What percent of people should have a score between 85 and 115 if the average is 100? Somebody impressed me, impressed the class. What percent of people should have a score between 85 and 115? All right, let me go over it. And look, after I go over it, really think to yourself. You're like, I think I'm smarter than this. I just choose to be lazy and to not pay attention. Watch. When I do it, and you're gonna be like, duh. Watch. Suppose the IQ scores have a bell-shaped distribution with a mean score of 100. The mean is 100. The mean is 100. The average is 100. The average is 100. A standard deviation of 15. One standard deviation to the right. The mean plus one standard deviation to the right. What's the standard deviation? 15? So then that would be 100 plus 15. What's 100 plus 15? 100 plus 15 is, I need a calculator. What's 100 plus 15? 115 is it, I think. And then the mean, subtract one standard deviation. That's over here on the left. So that's going to be 100 minus 15. 100 minus 15. What's 100 minus 15? Man, I need a calculator for that. What's that? 85. So it says right here, what percent of people should have an IQ score between 85 and 115? I think I already went over this. So in life, there's some data points where we can put it on a bell curve I think that's what it's called, and that sorry that what your mom told you. Your mom always says, everybody's mom says you're special, but more than likely you want to be we're just average, and 68% of people are just average because they're within one standard deviation of the mean. So that means that 34% of people fall to within there, and 34% fall within here, and 34 plus 34 is 68%. So when it says, what percent of people should have an IQ score between 85 and 115? And I think the answer is 68. Let me see, I'm still looking at people with eyes. People are, do I still have people who are like, I don't know what you're saying. I don't understand. It's like when we go, this is how you do so. It's funny how like you try to talk to somebody, you tell people, and they're like, you've said it like 100 times, and then finally the 101th, the next, they're like, why didn't you tell me that in the first place? That's because you were not getting it for 100 times before, and now you do get it. No. Anyways, let's move. So the mean is 100. 85, 115, 34%. The answer is 68%. One more. Let's do one more. Let's see if you now you're like, okay, I'm getting it. All right, let me read it for you. Let me read this for you. And after I read it for you, and you give me the correct answer, I will give you extra credit. Here we go. Let me read this for you. What's the probability? X is a score. What's the probability of somebody getting an SAT score greater than or equal to the mean plus 1 standard deviation? What's the probability of somebody getting a score higher than the mean plus 1 standard deviation? Higher than that. I will give you extra credit if you can give me the answer to that right now. You think you got it over there?
To get higher than the mean plus deviation, 13.5%.
That's halfway there. That's pretty good though. That's pretty good. That's pretty good.
15.85%.
You're getting so close to it. So close. 16%. 16%. Let me explain this to you. You already got it, but look. What's the probability of somebody getting a score that is greater than or equal to the average plus 1 standard deviation? Well, you need to really memorize this thing. So this is already the mean. You know that's the mean. This is already 50. You're better than 50. Then the mean plus 1 standard deviation. How much is this? How much is this right here? Just this. Wasn't this 34%? Look at what isn't this 34%?
So it would be 16 minus 100 divided by 2.
No.
That's what it would be.
Look. No. It's saying what's the probability of somebody getting a score that is greater than the mean of plus. The mean plus 1 standard deviation, greater than that. That's what it's saying. Greater than all these. That's all it's saying. We're not doing what we did before. We're not dividing. Why would we be dividing? They're just saying what's the probability of getting anything greater. So you're doing better than these people. You're trying to apply something else to something else. Just answer the question. You're doing better than these people. You're doing better than what? 50% plus what? 34%? What's 50% plus 34%? 84%. You're doing better than 84%, meaning you're in the top 16%. Oh, you almost got that 15.9 or whatever. You missed those on the... All right, let's do one more. One more. I'll give you extra credit if you can figure this out again. So let me read this out for you, or maybe you can just read it because I wrote it down. Here it is. This is what it says. What is the probability of picking an X value that is at least or equal to the mean minus 1 standard deviation, and also less than or equal to the mean plus 2 standard deviations? All right, who got it? Hmm? 81.5. It's just basic math of adding areas, subtracting areas, and knowing if you are you adding or subtracting. What did we say? Look, what is it that you need to memorize? What did I say? This is what? So it's gonna be right here is the mean minus one standard deviation. The mean minus one standard deviation. So this is what? 34%? Yes, 34%. And then this is gonna be the mean plus one standard deviation. The mean plus two standard deviation. Plus two. So this is what? 34%? How much was this? So what is 34 plus 34 plus 13.5? Or you could do what? 68 plus 13.5? Which is 81.5. Let's go to number 4. A normal distribution has a mean 1,000. That's the SAT. The average 1,000 on the SATs. Standard deviation of 150. Find the probability that a randomly selected X value from this distribution is in a given interval. Between 850 and 1300. You already got it over there? Don't say anything. Hold on. Who think they got it? Who thinks they got it? What percent of people fall within 850 and 1300 on the SATs? If the average is 1,000. Anybody? What? Who said it? Are you looking at the website already though? It's 81.5 also. Because what? What's 1,000 minus 150? 850? What's 150 plus 150? 300? So what's 1,000 plus 300? 1,300? It's just the same as we did the other one. All right. At least 1150. At least 1150. Don't say anything. This is getting repetitive. Anybody? At least 1150. Raise your hand. At least 1150. At least 1150. Somebody. Nobody wants extra credit? You got it over there or what? Huh?
Isn't it 16?
Oh, okay, we're done.